in the highly competitive domain of contemporary architecture and luxury interior design. A bathtub has transcended its traditional role as a mere utilitarian sanitary fixture. Today, it stands as a bold statement of wellness, a sanctuary of relaxation, and a defining centerpiece of high-end real estate. To construct a flawless, single-piece solid surface bathtub, characterized by a structural density that rivals natural stone yet completely devoid of visible joints or weak seams, the industrial journey must launch from the highly regulated environments of heavy metallurgical and chemical preparation facilities. This is where advanced chemical engineering and raw geological elements converge. The foundational phase of this process, which determines the entire mechanical and chemical threshold of the finished product, begins within the automated bulk material stockyards, the primary composite structural load, accounting for approximately 65% to 70% of the total product mass, consists of ultra-fine aluminum trihydrate, ATH, and pulverized natural quartz dust. Aluminum trihydrate is selected not merely for its mineral opacity, but for its outstanding material characteristics. It endows the solid surface with high impact resistance, exceptional thermal stability, and acts as a non-toxic, self-extinguishing flame retardant. This fine mineral dust is systematically channeled through sealed pneumatic transport lines to eliminate any risks of cross-contamination from the external environment. At the digital nerve center of the compounding facility, process engineers utilize programmable logic controllers, PLCs, to configure the exact material matrix with tolerances calculated down to the single milligram. In this high-stakes industrial environment, a mathematical deviation of even 0.01% in the ratio between the mineral fillers and the structural binders will cause catastrophic product failure, resulting in internal material brittleness or high vulnerability to micro-cracking under sudden thermal shock when hot and cold water mix. Once the precise mass of aluminum trihydrate is validated by digital load cells, the primary liquid matrix, premium methyl methacrylate MMA, acrylic resin, is injected into the system under immense hydraulic force. The acrylic resin functions as a macromolecular polymer cross-linking agent. It flows smoothly around every individual microscopic grain of mineral dust, encapsulating the stone particles and replacing the inherent brittleness of natural stone with superior structural flexibility and high tensile strength. Simultaneously, computer-calibrated liquid pigments are micro-injected into the resin stream, creating organic, hyper-realistic marble veins or achieving pristine, unblemished monochromatic color palettes. The combined slurry of mineral dust, liquid acrylic resin, and stabilizing pigments is directed into the sealed belly of an industrial-scale vacuum mixing chamber. Inside this stainless steel
preparation
vessel,
phase
dual
is
helix
successfully
counter-rotating mixing blades engage at synchronized speeds, aggressively shearing the material to enforce complete homogenization while strictly limiting internal friction-induced heat. The critical engineering mechanism during this phase is the constant application of a deep vacuum environment. As the dense material is agitated, millions of microscopic atmospheric gas bubbles become trapped within the viscous slurry. Without a powerful negative pressure vacuum system to constantly pull these micro-bubbles to the surface and collapse them, the finalized casting would suffer from high gas porosity, internal voids, and superficial pitting defects. The homogenized solid surface compound, now in its liquid viscous state, is immediately discharged via automated bottom valves and directed toward the heavy molding division. This sector represents the domain of colossal hydraulic press assemblies and massive industrial tooling molds, where the initial mechanical dimensions of the bathtub are established under uncompromising technical oversight. Each independent mold is a masterpiece of precision mechanical engineering, CNC machined from solid high-tensile steel alloys designed to withstand repeated cycles of extreme hydraulic clamping pressures and dramatic thermal fluctuations without exhibiting any geometric distortion. Before the white liquid stone compound is introduced, the interior cavity of the massive single mold undergoes a meticulous preparation sequence conducted by specialized technicians. First, the operators utilize high-pressure pneumatic air lances to eradicate any trace of foreign particulate matter. dust, or microscopic fibers that could be resting on the reflective steel surfaces. Following this, a specialized chemical release agent is electrostatically atomized and applied uniformly across the entire internal geometry of the mold cavity. This ultra-thin chemical barrier is highly critical. It prevents the aggressive acrylic polymers from physically adhering to the tool steel during the thermal curing process, guaranteeing that the massive bathtub can be cleanly separated from the mold without fracturing. Upon completion of the structural inspection, the lower half of the steel mold is hydraulically locked onto its heavy foundation plate. An overhead gantry crane positions the automated delivery manifold precisely over the mold's central axis. The delivery valves open via automated pneumatic actuators, and the pristine white stone compound begins cascading into the mold cavity. The volumetric flow rate is strictly regulated to prevent turbulent flow conditions, which could reintroduce unwanted atmospheric air pockets into the liquid stream. The automated nozzle moves along a pre-programmed linear path across the 2-meter length of the bathtub mold, ensuring that the heavy material completely fills every tight ergonomic angle, from the reclined backrest to the thin structural rim perimeters. As soon as the calculated volume fills the internal void, the upper core mold, the male plunger assembly, descends under the control of massive hydraulic pistons, compressing the viscous stone composite with immense mechanical force. Simultaneously, a high-frequency 3-dimensional vibration table integrated into the mold foundation activates. The entire multi-ton steel assembly begins vibrating at a calculated frequency and a minute amplitude. These intense mechanical oscillations generate a localized fluidizing effect within the dense slurry, forcing the heavier mineral particles to pack tightly into an optimal geometric configuration while driving any stubborn microbubbles upward toward the engineered overflow vents of the parting line. Following the compaction and stabilization cycle, the mold enters its most critical phase, the thermal polymerization and curing sequence. High-pressure steam is circulated through a complex network of internal heating channels built directly into the steel mold walls, elevating the system temperature to trigger the chemical catalysts within the acrylic resin. Under this thermal influence, the monomers within the methyl methacrylate resin break their double carbon bonds and link together, forming a rigid, 3-dimensional cross-linked polymer network that locks the quartz and ATH particles into an unyielding matrix. This polymerization reaction is highly exothermic. The material generates its own internal heat, permanently transforming the liquid slurry into a solid stone monolith. While automated machinery, heavy hydraulic systems, and multi-axis CNC routers excel at enforcing strict dimensional and geometric tolerances, they lack the sentient perception and tactile sensitivity possessed by a skilled human artisan. The bathtubs emerging from the heavy molding sector are structural masterpieces, but their surfaces are raw, dull, and characterized by minor micro-textures left behind by the steel mold interfaces. To convert this raw stone mass into an exquisite piece of functional art, one that possesses an ultra-smooth, luxurious gloss that feels warm and comforting to human skin, the product must undergo an intensive manual refinement process, the art of multi-stage hand polishing. Within the brilliant illumination of the final finishing bay, each independent bathtub is assigned to a master craftsman who takes full ownership of its surface morphology. The artisan's work initiates not with mechanical tools, but with a traditional tactile evaluation, sliding bare fingertips slowly across every square centimeter of the interior and exterior curves. The highly trained tactile senses of the craftsman can instantly detect micro-imperfections, subtle undulating waves, or minute density variations that would be completely invisible to the naked eye or electronic scanners. After mapping out the areas requiring structural leveling, the artisan activates a high-speed pneumatic random orbital sander equipped with a coarse P120 grit abrasive disc. A steady, uniform mechanical roar echoes through the workspace as the spinning sanding disc makes contact with the solid surface, releasing fine white stone particles that drift away smoothly like dense industrial snow. The artisan moves the sander with fluid, sweeping arm movements, maintaining an absolutely consistent perpendicular force against the stone to avoid creating flat spots or undermining the ergonomic curves of the bathtub architecture. The sanding process follows a strict, multi-tier abrasive hierarchy. After the initial coarse disc eliminates the major surface imperfections, the craftsman systematically steps up the refinement level using progressively finer abrasive grits, from P240 to P400, and up to P800. From the P400 stage onward, advanced wet sanding techniques are introduced to the line. A continuous mist of demineralized water is applied to the stone surface to serve as a coolant, preventing frictional heat from causing localized thermal distortion in the acrylic matrix. The water also functions as a powerful lubricant, ensuring that the fine abrasive particles shear away